Alright, this is 2023 O levels trigonometry part B, question number 4. Okay, see, Chamara and Amal are standing on a level ground on the opposite sides of a vertical tree KT. Okay, as shown in the figure. Amal is 30 meters away from the tree, so the distance AT should be 30 meters. And then Chamara is flying a kite. The kite suddenly gets entangled on the top of the tree, so that is K, such that the string is taut. So the string has tension. Alright, the string is 40 meters long. 40 meters. Okay. At that moment, Chamara sees the kite with an angle of elevation of 44 degrees and 50 minutes. Okay. So Chamara's angle of elevation disregards the heights of Chamara and Amal. So we have to copy this figure down, and then we have to use trigonometry to answer the following questions. Okay. See, this second part of the question asks us to find the height of the tree KT. So if I draw this KCT triangle, we know this angle, that's 44 degrees 50 minutes, and we know this height 40. So we can easily find the KT distance. You know, this is the opposite side. We have to find the opposite side for this angle. With respect to this angle, it's opposite, and we have a known side, that is the hypotenuse. So opposite and hypotenuse are related with the sine ratio, sine theta. Sine theta is opposite over hypotenuse. Okay, so sine 44 degrees 50 minutes, that's KT over 40. So KT would be 40 times sine 44 degrees 50 minutes. Now we'll have to find sine 44 degrees 50 minutes. Okay, we have the table of sines. 44 degrees, this is 44 degrees 50 minutes, so this is 50 minutes column. 44 degrees 50 minutes is 0.7050. Okay, 0.7050. So 40 times 0.7050 is KT. Okay, so you know 4 times 7.05, right? So that is 28.2 meters. KT would be 28.2 meters. So the answer for the second Roman number is 28.2 meters. And then they are asking us to find the angle of elevation with which Amal sees the kite. Okay, so Amal's angle of elevation is this. For that I'll need the triangle KAT. KAT, will have to find this angle, right? And we know this length now, that is the length of the tree, so that would be 28.2. we also know this length, that is 30. Now we can find the angle. With respect to this angle, this is the opposite side and this is the adjacent. Opposite and adjacent are related with the tan ratio. Tan theta is equal to opposite over adjacent. So tan theta is equal to 28.2, that is the opposite side length, and over 30. So this would give us 0.94. Tan theta. So theta is tan inverse 0.94. Alright, tan inverse 0.94. We'll have to find the inverse of the tan inverse of 0.94. So let's go to the table of tangents. 0.94. 0.94. We don't have 0.94, but we have 0.938. So that will do. 0.938, that is 43 degrees and 10 minutes. 43 degrees and 10 minutes. And we'll have to add 20, like 0.0020 we'll have to add to make this 0.94. Right, so there's no 20 in the mean difference column, there's 17, that's in the third column, so we'll have to add 10 to 3 minutes. 43 degrees 13 minutes. Okay, so the answer would be 43 degrees 13 minutes. Theta is 43 degrees 13 minutes. Alright, so this is 43 13. Now with reasons state which of the two Chamara or Amal is standing closer. So if you are closer to a building, so suppose there's a building and you are here now, so the angle of elevation would be this. So let's say alpha, right? And you, as you get closer, the angle of elevation changes. Now it's, let's say, beta. What can you say? Beta should be greater than alpha, because you are closer to the building, you have to tilt your head further to look at the top. So the angle should be higher when the person is closer. Now there are two angles, 44 degrees 50 minutes and then 43 degrees 13 minutes. So this is the great angle, which means this person is closer. That means Chamara is closer. So this is the reason, the inequality. Chamara is closer. So that's the end of the fourth question.